Did anyone tell your classmates to join? Just share the link once.
We have shared in J section, Sukalia.
Yeah. Uh,
Hello.
Hello, sir.
Hi.
Uh,
Yeah. My voice is we'll start. We're still waiting for somebody.
yes, sir. Sure. We'll start now. So, let me just give an introduction.
Yeah.
So, yeah. Thank you, each and everyone, for joining here today. We are very appreciative about your support for this event. We know you all are very busy, and thank you for taking some time for us. Also, I would like to express my sincere appreciation to all of those who generously helped us in making this event come together, which is our speaker, Mr. Kumar, who has a PhD and is head in data science, his architecture lead at Larsen and Toubro. And also special thanks to my campus club Coachella. So before we begin, there's a reminder that you all will be getting a 50% off on Coursera courses for the first month of the program. So make sure that you fill the feedback form when you receive it through the deeplearning.ai mail. So yeah, so you can start now.
Okay. So thanks, Sukanya, for the session. So to be frank, I'm not quite clear about the composition of the participants. Okay, so the expectations or the objective of this session is to introduce you know the fundamental mathematics behind uh, no, neural networks. Okay, very fundamental. So I'm assuming that you have some fair idea about in general data science or any machine learning or AI, and this will give us underlying concept so that it will be easy to understand as you go deep and deep into these neural networks. Okay, so that is the agenda of this. So let me present my screen. I hope you can all see my screen clear.
Yes.
Okay. So just introduce myself to all of you. So I'm Shaila. So I'm a PhD scholar and MBA and BTech in my past. And I'm a core banking background person. Almost 14 plus years I have been with various banks like HSBC, Wells Fargo, Standard Chartered, all MNC banks. And I'm a risk professional by interest, and then I'm a management professional with various credentials like PMP, PGMP, and I was also Indian School of Business alumni. Okay, so I'm working with Larsen Toubro, which is a multi-billion-dollar company in India, predominantly into engineering side of engineering field particularly. So I'm part of L&T Smart World and Communication, which is a business unit. We deal with smart city related projects. Okay, we'll talk about that. What are those smart city projects? And I'm heading the data sciences part of the company. And so before that, I was with various other organizations: IBM, HSBC, Wells Fargo, Standard Chartered, and also I spent some small time with the government of Andhra Pradesh as a delivery head for their entire analytics division. Okay, so this is very brief about me, and this is an agenda for today. So we'll talk about what is data science. Probably some of the things may be a sort of a repetition for you because you're already. I'm assuming that you are already somehow connected to data science. So types of algorithms, because I just want to derive, what is so special about AI, and apart from neural networks, what other models are available or algorithms are available, what for we use that. So you'll get a big picture about various types of algorithms, and then now we'll derive what is neural network, the types of neural networks. And then we'll talk about very high level some use cases with various domains. And I have a couple of slides where what we did, personally from my team, the real time implementation of neural network based applications, and then typical architecture of any AI infrastructure or ecosystem. Then a small demo, so which is because I'm trying to explain you how neural networks works with a simple Excel. Okay, no Python, nothing. And then we'll see what are the challenges with neural networks, and then time permits the last 10-15 minutes we'll talk about question and answers. Okay, so I think you might have seen this definition the moment you type in data science in your Google. So data science is a combination of various concepts. One is data, and one is software, and one is mathematics. Okay, statistics, algorithms, etc. So a data scientist should have the flavors of all these three areas. Okay, so otherwise, the if you cannot define a problem statement, so you cannot solve something. And once you define the problem statement, so you can apply any algorithm available in the market. But if any of those algorithms are not suitable to you, then you have to create your own algorithm. So for that, you need a mathematics and statistical background. Though any model algorithm is available to you, to test those algorithms, again, you need a statistics. Like, you have to perform various tests on the outcome and then see whether this algorithm is a fit for usage in production or not, etc. Okay. And of course, to implement these concept algorithms anyway, so you have to have a computer software background or knowledge. Okay, so what industry expects from a data scientist, to be frank, I call this as a full stack data scientist. So these are the flavors, they expect from an individual data scientist. So fortunately or unfortunately, data scientists today available in the market are very expensive. Okay, so probably, a 1 year, 2 year experienced guy asking close to 20 lakhs. Okay, of course with some premier institution and with a good track record. Okay, so that is a common phenomena today. So as organizations are ready to pay 20, 30, 40 lakhs to such individuals with a very less experience, then expectations also will be accordingly high. Okay, so what are those expectations? Okay, so it's not that a traditional software cycle where there will be client will give some requirements in some form, and then in any organization, say for example in India, so there is a business analysis team, right? So they will try to elaborate the customer voice into a proper structured requirement document, and then there will be some architects or designers so who will convert that into a technical documentation. Okay, what technologies to be used and what is the volume it will process and how many transactions is supposed to process, or whether it is through API or whether it is through JDBC, ODBC. So all engineering aspects will be taken care by architects and designers, and then later it will come to developers as well as to the testers. So testers will continue to do their test strategy, test case preparation, etc. And then parallelly, developers will start, converting the document into a programming code or language, right? And then finally, testing will happen, integration testing will happen, and finally performance testing will happen, and then finally it goes to production. But in the typical data science project, so you may not follow this traditional waterfall type of model, and also the problem definition where data scientist himself will be taking either a complete role or probably a contributor role. Okay, and then that guy, because he knows what can be done, what cannot be done, because customer may ask you that, okay, I want to detect something, but data science has its own limitations, right? It cannot do everything for you. Okay, so as a data scientist, you can see the capability of the technology and then see how we can convert your requirements into a form where it can be achievable. Okay, something like that. So problem definition is and visualization of what is the outcome. Say for example, somebody says that client says that, okay, I will give a weight of a person, height of a person, and then you have to detect or predict, okay, age of a person, say for example. So that is a simple requirement. So all good, but you need to visualize the outcome, like how customer will pass height and weight, and then how you are going to represent or present your outcome, that is your age, right? So either a screen required, or some API response is required, or you are going to write something into a database or somebody pull the data from there. So we need to understand, visualize what will be the outcome and how the user or client interact with your AI use case, and then get the required outcome, okay, to them. Okay, so that's where we have to visualize the outcome and usability, how they are going to use this use case. So most of the cases what happens, customer ask this height, weight, and then you want to give age. Somebody writes some Python code. Okay, boss, everything is fine, excellent. Okay, take this Python code. What somebody will do with that Python code, right? So we need to do a lot of engineering around Python code to make that useful. Okay, and also we expect data analysis and the statistical background, and then model development anyway, that is a core competency of any data scientist. and model validation. So this is where the problem, because as I told, it is very easy to write a code. You have all code snippets available in internet, Google, and then you can immediately do it. Any big model you can do it in a days, provided you have the computing power. But whether that is really giving the intended output or not, nobody knows, unless until you do model validation properly. So there are so many model validation techniques are precision, recall, accuracy, F1 score, etc., etc. So one should know what are those concepts and how to improve a particular parameter or performance parameter of a model. Okay, so that is very important, model validation, because it's also one reason why I'm telling you this is, if you go to any cloud computing, right, so AWS or Azure, so they have a drag and drop of facilities. You simply connect your data and then pull what model you want to use, and convert your data into two pieces, test set or train set, and then you simply plug your train set to your model, and then your model is ready. And then there is a validation also can be drag and drop, so you can put a validation, but validation will give you so many parameters. So one should understand what are those parameters, right? If for example, if it's simple regression, what is R square, adjusted R square, one should understand what is that. And there are so many statistical tests. There is p value, there is t value, there is z score. So one should understand all these concepts, then only they will validate the model properly, right? So that's why this is utmost important, validation. No tool will validate for you, but they will give you the outcome. They will throw you so many numbers at you, so you are supposed to understand those numbers and then take right decisions. Model optimization, this is very very important. I will talk about this. Model optimization is extremely important when it comes to neural networks, because as you implementing a very high end neural networks, right, there will be probably hundreds of hidden layers, and then hundreds of neurons in each layer. But if at all you want to use this model in production, so there will be thousands of weights has to be maintained for that model. So is there any way we can cut short the number of weights so that your model will become lightweight, and then its online real time performance will be much better? So there are so many optimization techniques tools available in the market, and what it does is it will simply remove all the neurons from your network, those which are not contributing to detect or to predict your outcome. Okay, so those areas are called optimization. And DevOps and ALML pipeline, so this is very important. you know as your organization, for example, if you are working with a big banking organization or probably manufacturing organization, you may be dealing with hundreds of models. So how these hundreds of models data will be connected? Okay, hundreds of models are connected, and then where these models supposed to take the data, and where these models supposed to copy the predicted values, or there where they supposed to take the configuration items, and which place we supposed to expose this in the form of an API, or probably as in the form of an event or alert, etc. So this entire DevOps pipeline is very important, because this model is not one time activity, right? Today I can train my model by using 1,000 images or 5,000 images, but that is what I have today. But as I started producing, and as I started deploying this, and then I'm keep getting more and more information, so my model is continuously under training. Every week or every day or every month, based on your type of use case, I keep retraining my model. So this retraining pipeline has to be established, and all those things, like where the data is coming, processed, going. So the entire DevOps pipeline has to be established. So it may not be the case with everybody, but as I told you, if at all you have a big ecosystem of algorithms or use cases with probably 50, 60, 70 or 100 plus, then we have to have all these automated. Otherwise You cannot handle those many number of models, those many versions of your models, etc. Model deployment, this is utmost important because I have been interviewing many people for last 1 year or so for my current organization. Probably most of the people are good at model development, and beyond that they were not quite comfortable because they used to tell me that, sir, there is a model deployment team. Okay, so I'll give some pk file or some file, and then they will take care of, how they will take care of, you may not be aware. Okay, so model deployment is very important aspect for any data scientist. And the GPU CPU based model training and interface, so the moment you are talking about neural network, so CPUs may not be sufficient, so we should also understand how GPUs works and then configuring your model for GPUs, etc. On-prem cloud, so majority of the organization, big organizations, probably they may be having their data centers where you will be installing physically into their data centers. And also nowadays, for a medium size or small scale companies, so they don't want to spend money on a physical infrastructure, right? So they will go to cloud on usage basis. They will get pay, they will get the bill or invoice, so that it will be easy for them. The majority of the times, cloud providers will handle everything for you, so you need not maintain many administrators and the network engineers, and all those things will be avoided. So we should be in a position to understand how these models will perform either on-prem or on cloud-based ecosystem. Visualization is a very very important thing. As you all know that probably 70% of our time will go for understanding the data, and understanding the patterns of the data, the distributions of the data, or various summary statistics of your data. And sometimes it may not be simple writing some R code or Python code, but you have to visualize that on either Tableau or Power BI and whatever tool we're talking about, so that you should have definitely a good understanding of the visualization. Because if you see, once a model will throw some output, so that output has to be presented on a graph or chart, okay, or in a tabular format, so or in the pie chart, so many things, in so many ways, we can present the data for end user to take a decision. Okay, so visualization we expect to know. User interface development, so I may not be pushing this on everybody because it is a completely different ball game. But as a Python developer or as a data scientist, you are not supposed to you know dependent on some full stack developers, or probably some React developers or Angular JS developers or HTML developers, etc. So the moment you have your own model, so you should be in a position to test that, to visualize yourself, because how many times you keep on watching the output in your Python code. You cannot even show it to your manager. Okay, boss, I am completed my model, because your manager may not be understanding anything about data science. So he only needs that, okay, take some input, weight, height and weight, okay, age is coming, and this age is more or less close to the real age. So that's how we can present your case to your management, right? So I suggest that there are few tools available for for UI. For R programmers, they will go to Shiny app, or for Python developers, there is Dash is one UI tool. Steamlit also is one of the tools. So there are two other tools are available, so you can check it. And before it goes to production, so probably it will go through a formal front end design, etc., etc. So feedback mechanism, so this is what I'm talking about. So once you deploy the model, so we continuously get the feedback from the production, so that that information can be further used to retrain your model for better performance of your model over a period of time. Okay, so databases, data warehouse, data lake, data mart, so big data ecosystem, if you know a little bit, so it's well and good. And the knowledge of operating system. Okay, so I'm not much worried about, but at least I feel that you should be in a position to work with your console. either Ubuntu or CentOS or whatever the Unix based operating system. So you should be versed with the commands there. Okay, so let's talk about the various algorithms. So this is what my personal opinion. Okay, and uh, each individual probably having their own mind map, but this is what my mind map. Okay, so I prepared myself for my team to understand, and wherever I speak like this, so I use this slide generally. So predominantly, if it comes to analytics, so we're talking about descriptive analytics, where it will describe the data. Okay, so it includes basic statistical techniques of understanding mean, variance, standard deviation, skewness, kurtosis, quartiles, distributions, etc. And next is the predictive analytics. Sorry, prescriptive analytics. So it talks about operational research models, right? I think most of the data scientists today, they may not be aware of this area at all, right? I don't know whether they don't like it, or probably they were not probably didn't learn that during their courses. I'm not sure, but operational research models are very, very important. And these techniques are very widely used in many fields uh, of this economy. Okay, so where we're talking about linear programming, integer programming, non-linear programming, dynamic programming, simulations, all those things will come under this prescriptive analysis. I hope you are all aware of prescriptive analysis analytics. So it is required only very small data to predict something. Okay, it is not a machine learning type of algorithm. It is more of optimization algorithm. Okay, so for example, if you want to go from one place to another place in Delhi, say for example, so what is the right road you should take so that you will travel a less distance? Okay, so that is one optimization model. So it will optimize the distance you cover. But some of the other people, they feel that okay, boss, distance is fine with me, but I want to reach in the shortest time. So then I have to consider the road sizes and then the road traffic conditions, etc. And then I will give him another path which will be the shortest with respect to time. Previous one is shortest with respect to distance. So that's the reason. So this is more of I'm prescribed. Customer will come to me, boss. I have this demand, and this is what my supply, and these are my problems or constraints. Okay, constraints means a particular uh, mission can only produce 1,000 units per day. So that is a constraint. It cannot produce more than 1,000. So by keeping those constraints, and then this mission may take approximately 90 rupees to produce 1 unit, and then he set up some another manufacturing unit that can produce 2,000 units per day, but it cost probably 95 rupees per unit because of the local labor cost or electricity cost, or probably because it is very close to city, so the land cost. So there have been so many factors influence for unit cost of production, right? So so now you need to balance this out. How many you have to manufacture from the unit one, which is less capacity but is less costly at the same time. But the second one is higher capacity but cost is also little higher. But my demand is, say for example, 2,500. Okay, so how many I should produce from here, or how many produce from here, so that my overall cost will reduce. I'm not only talking about overall cost of the production, but also, the transport cost or logistical cost. So we have to consider all those things, and then I will prescribe to this particular client that okay, mission A or plant A, you produce 750 of this type of units, and plant B, you guys supposed to produce probably 1750 or whatever, to meet the demand of this particular customer. This is called prescriptive analytics. Okay. The other one is the predictive analytics. I think many of the people are very comfortable with this. So it's all comes under supervised learning. So regression is a very basic thing. So regression also many people don't know beyond the linear regression. Okay, logistic. I'm not talking about logistic here. I'm only talking about you know uh, I'm not talking about classifiers here. Okay, so simple, you know predicting, either continuous value or probably discrete value. Okay, so linear is the one many people will be very comfortable. Many people, I'm telling you, don't know about what is Poisson based regression and the negative binomial regression, zero inflation, Huddle models, Kaplan-Meier, Cox-PH, Weibull. There are so many models are available. Many people are not quite aware of these. That there are some models exist like this. Okay, and then it comes to classifiers. So of course, here the logistic, multinomial, naive Bayes or Gaussian mixer, decision trees. Of course, decision trees are very popular. Logistic is very popular. Random forest and all, of course, popular. Most of you might have done a lot of work in this area. SVM is also popular. KNN. So these are all traditional machine learning models. Okay, then this is where the deep learning, so this is the topic of our discussion today. So deep learning models is all about perceptron, backpropagation, MLP, CNN, RNN, LSTM, encoder, decoder. So these are all various concepts available in this particular area, so how they will be useful. So I will take one base example. There is no rocket science at all in any of these models. Not only deep learning, all these models are very simple. Only thing is we need to understand very basics about the mathematics behind these. Okay, unsupervised learning. So all these clustering, dimension reduction, and recommendation systems, like if you go to Amazon, so they will recommend you so many things based on your past history or buying history, or probably a person like you bought say similar one book in the past, and he also bought some other book. So that book also be recommended to you, because system feels that you and that guy who bought that book are similar type of people. So they feel that okay, this book may be also useful to you, something like that. Okay. So market basket analysis, page rank algorithm. So page rank algorithms is widely used in digital marketing space. Who is clicking what, and then how a person will click and then go to a page, and what is the the weight of that page based on the links it has, and then how many pages are linking referring this page, or how many pages this page is referring. So all those calculations are part of your page rank algorithm section. Network analysis, we're talking about if at all you want to start up a new flight route, say for example, or train route or a bus route, say for example, in a network of various junctions and then bus stands, bus stations, or cities, etc. So where you're supposed to operate so that there is a chance that this new route will be successful. Okay, so all those things you can do. These are all predominantly unsupervised learning. Market basket analysis, like if you go to any shop here, any supermarket, if you buy milk, probably you may buy curd also, or if you buy milk, you also may buy cornflakes flakes, or if you buy milk, you may also buy banana. If you buy bread, you may also buy eggs. So these are all like patterns it will find out from the data, and then it will try to recommend you in case of retail online. But if at all in case of physical shops, then what they will do is they will keep these items you know in certain sequence, so that these things will not be missed by you, and then you will definitely buy it. Okay, so those are the techniques comes under unsupervised learning. And the reinforcement learning, which is relatively new. So this is all about real time. These models will learn things. Okay, because if a deep learning type of models, it requires a huge data. Okay, and a huge computing power. But unfortunately, that may not be working for some sort of problem statements. Like for example, let's take chess game. Okay, so in chess game, how your deep learning really understand all the moves. Okay, so it has to be trained with so many of winning strategies, and then it automatically start moving, the coins based on its historical knowledge. But it will be very difficult when it comes to that type of things, or gaming particularly. So gaming, it's more of real time, right? Okay. So you cannot understand all permutations and combinations of a game, so that a computer will probably win over you. Okay, so those are the places where reinforcement learning is very useful. It's picking up the momentum along with the quantum computing. So these are some items in that particular area. So this is what my way of classifying various algorithms. Okay, so you can classify in our own way. Okay, absolutely no problem. But so unsupervised will become unsupervised only. Okay, there is no change. Okay, so for all these models, we're talking about this covers predominantly 70-80% of the models as far as I know. And the basic mathematics behind are very very simple: basic probability and simple correlations, and sampling statistics and hypothesis. This is also, we don't use high end statistics, low end statistics only. And the distance measures, and some sort of derivatives, and optimization techniques. So these are some of the mathematics behind any of, okay, these models. Like for example, probability based models, right? It's all classifier, like logistic regression uses probability. Okay, covariance correlation. Your regressions are all purely based on the correlation. Okay, sampling statistics hypothesis. Anyway, this is common across everything for for validating your models. Distance measures, for example, take SVM, or in case of regression also, it is all about distance of a actual observation with respect to the line you are trying to build. So we are trying to minimize that. So minimization is all about optimization. Okay, so that's why don't be worry about, okay, this area is very complex. I feel that this is one of the simplest topics, but created a complex concepts out of this, nothing else. Okay, so let's go back to our topic. I think, I don't know what is the time, so it's already half an hour. Okay, so neural networks, guys. So what is neural networks? The neural network is a series of algorithms that endeavors to recognize underlying relationship in a set of data through a process that mimics the way the human brain operates. So this concept is derived from the human brain cells. I think you are all aware of that, and how the human brain cells works. So we are trying to mimic that and see whether this concept really think like human brains. I think at a certain extent it is definitely doing that. Okay, so each node here is like a brain cell of our human brain. So we'll talk about how this works. Okay, don't worry, I am giving you the simplest of the examples so that you never forget what is neural networks. Okay, so in this sense, neural networks refers to systems of neurons, either organic or artificial in nature. So neural networks can adapt to changing input, so the network generates the best possible results without needing to redesign the output criteria. Okay, so don't worry. So we'll go to the next screen. Types of neural networks. Okay, so before we get into neural networks, we'll talk about, okay, fully connected network, convolution neural network, recursive neural networks, and the LSTM, long and short term memory networks, and then encoders and decoders. So predominantly, you will use convolution neural networks for any object detection type of things. Okay, from videos or images, and recursive neural networks and LSTM generally you will use in text analytics, to be frank, because if you see in a Google, right, in a Google Mail, okay, so the moment you type one or two words, it automatically recommending you the next word, right? So that is the place where RNNs and then LSTMs are predominantly used, because these networks really required to store the context of what you already written. It's not about, okay, I'm writing one word, and then it is not, the next word is not purely based on my previous word. Okay, my next word supposed to be a combination of previous few words. So that's why it has to store temporarily the previous information, so that it can predict and derive the right prediction for the next word, what will be the right word. So that's why we are calling this as a long and short term memory. It will store, the storing means it is creating it, it is getting its own context. And then it will say, for example, if you go to a movie, okay, so fighting and dance is common, right? In Indian movies, so fighting is very common. And after fighting, so hero wants to relax, and then he will have a duet with the heroine. That is a traditional pattern. But for every movie, there is a specific background why this guy fighting. Okay, and every movie, why this guy is dancing, whether he got a rank, or whether he was successful in a business, or is his girlfriend accepted his love, or what, there will be many reasons why somebody celebrate, right? So that the context is the one which we are going to store in a short and long term memory, so that system will get the better understanding. Okay, what happened previously, so based on that, okay, I have to throw this type of word. Okay, so predominantly that is a place they will use. Or also test conversion, right? If today, earlier, if a Google CEO, or probably Microsoft CEO will go to China or Russia, so they need a translator. Okay, so somebody, or for example, from North India, people come to South India for election campaign, and vice versa, right? So if somebody coming from the Hindi world and then talking in Tamil Nadu in Hindi, nobody will understand. So what happens, for every sentence, there will be a guy who knows both Hindi and Tamil. They will keep translating. But unfortunately, now we don't have that problem, because while I'm talking in language, in whatever language you want to translate that into, so that can be presented in the on the screens, okay, behind the person who is talking. The latency is very very small, so we can avoid all these confusions, etc. Okay, so that is a place where it is continuously predicting the right word, so that it will avoid any misquoting of what this guy is really talking in a different language. So what you can do with neural networks, so you can do anything to practically. You can do classification, anomaly detection, speech recognition, audio generation, time series analysis, spell checks, character recognition, image processing, etc., etc. We are doing a lot of image processing stuff for my company. Okay, so I will give you one or two use cases. Okay, so it's simple. This is how the human brain works. Okay, so it has some connections to the other neurons, and all those neurons keep on sending some information in some form, and based on that information, this cell will take a call, okay, whether to go this direction or this direction, or whether to ignore, or whether to stimulate something. Okay, so based on the outcome of this particular cell, the information will be passed to the next cell. So like this information is keep on flowing across various cells till it reaches a conclusion, and then we'll speak out, or whether we recognize, by our eyes will recognize, etc. Okay, for example, 10 years back you met one of your long relative, and after 10 years, you changed and that guy changed, right? A change happens, it's a natural phenomena. So it will take some time for you to recognize that guy. So you have to, you know your brain will think or capture various information. Okay, this guy, that city, that function, this place. Okay, so it takes a lot of input like that. and then it will enrich the information as it goes through various channels within your brain. Finally, you may recognize, it may be right or wrong, okay, so it may recognize, to conclude, okay, it will come to a conclusion, oh, this guy is an X. So most probably, if your brain is working well, so probably 70-80% of the time you are right, but 20-30% of the time, you may be wrong, because you are unable to recollect the right inputs, so that your processors, like your neurons will not process properly, so that finally you have to ask, take excuse and then ask the name. Okay, so the same concept, our researchers are actually converted into a digital form. That's all. Okay, so it will take a lot of inputs from inputs, in the sense, like, for example, my eyes is an input, okay, and my nose is an input. For human being, these are all sensory. How many sensory organs we have? Eyes is, of course, the very important one. Second one is nose. Third one is your tongue. Fourth one is your skin. And what is the ears is your fifth. Okay, so these are the five sensory organs which will take input from the world, and then your brain is your central processing unit, take all these inputs and then cook up something, and finally it will respond back. Either you are recognizing some person, or you are able to identify what smell you are experiencing, or what music you are hearing, whether it is Kumar Shanu, or I don't know, Kishore Kumar or SPB. So all these things are the outcomes of the input coming out of all these sensory organs. So this is exactly same thing. So these are the inputs, and then I do some mathematics. Okay, so technically I have to convert any neuron into a mathematical function, and then it will trigger something, and finally it will give you some outcome. Okay, so it has two things: this calculation function and then decision function. Okay, we call that as an activation function in neural networks. So it has two algorithms: one is a perceptron and one is reverse propagation. So simple equation is like this. Okay, it is very simple. The weights of, see, for every place, okay, I will talk about what are those weights and all. So let me open my Excel, so from there we'll go. Okay, so okay, so let me take my Excel. Okay, hope you can see my Excel. Okay, can somebody confirm Excel?
Yeah, it's showing.
Okay, see, boss, this is called perceptron. Okay, this layer. Okay, I'll tell you what is this layer, and this is called back propagation. Okay, so these are the two things keep on happening till it achieves the intended output. Okay, I will tell you a very simple example. Okay, so let's, you go to a doctor, and this doctor will decide a medicine, or probably the severity, or probably he want to score your health, for example, in 1 to 10 scale or 1 to 5 scale. I don't know, I'm just giving you an example. So these are the values of your various inputs. So the inputs here are temperature, BP, pulse, whether you have cold or not. Okay, this is a toy example, guys. Okay, don't quote me. This is how doctors will do it. Okay, so these are four parameters he will take, and I'm calling those are x1, x2, x3, x4, and then uh, I have to find out what is the value of my output based on these inputs. So what I will do is I have to give the weightages to each of the input values. Okay, you don't worry about these weightages. System will give some default weightages, but here I want to give some weightages, 0.1, 0.1, 0.1, 0.1 as a fixed to start with. Okay, what are these weightages? Because based on these four parameters, with some weightages of these will decide your output. So I want to multiply with some value because this will not change. This is fixed. But I keep on changing these weights so that it will give me the intended output. Okay. So now I given 0.1, 0.1, 0.1, some numbers. Okay, you don't worry even about that. Okay, some random numbers, but I given 0.1. Okay, and don't worry much about bias. Bias is an external stimulation. If there is a decision taken based on these four is not taking any action, so this will help us to activate my neuron. Okay, so this is also, if you know the regression. So regression has an equation, right? What is the regression equation? Okay, y is equal to beta 0 plus beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3 dot 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 and then some error. See, that is what your regression equation. So here the beta 0 there is called intercept, right? So I am talking about this bias is also like an intercept. And then all beta 1 into x1, right? So this is what my beta 1 is 0.1, 0.1, 0.1. X1 is these values. So any neuron, one neuron is like a regression equation, guys. That's all. And unfortunately, with the regression line, regression is one straight line. With one straight line, I cannot, identify an object in a picture, or I cannot understand, if at all my pattern is something where my outer circle is something, inner circle is something. So straight lines cannot separate various classes of the observations. So that is the reason we go with a combination of many regression equations so that I can form any shape. That is the only change between a single regression equation with either nonlinear equations or with neural networks. Neural networks is a combination of many lines. That's all. Okay. So now you understood, right? So this is a simple regression equation I am trying to build here. Okay. So this is a single neuron. So once this neuron takes this value and these weights and then finally calculated this as a 1.7. Okay, so this is an equation. B, that is bias, plus x1 into w1 plus x2 into w2 plus x3 into w3. Simple equation, nothing else. It given me a point value as 1.7. But actually I'm expecting 5 because this is a supervised learning. Hope you are all understood, right? Now this is a supervised learning. So while doing my training, I already know what is outcome. But I am only teaching my model. Okay, boss, if you get this data, you supposed to give me 5. But in this case, it given me 1.7. Okay, so I don't accept that. Then what I will do is, I will find the difference between these two. What is the output value of this neuron? And then what is the actual value? So that is 5. So 1.7 minus 5. So I get some value minus 3.3. Now, how I can reduce this difference? So to reduce this difference, I have to change something here, right? Because I cannot change this because this is fixed. This is coming from the external world. By my model, these are all my weights I call. I have to change these values such a way that it will give me or it will minimize this so-called difference that is called error, right? Any model if you take, the major objective of any model is to reduce the error. Simple. No ambiguity there, right? So here also I'm trying to reduce my error. So how to reduce my error? So what I will do is, that is the formula I was showing here, right? So this is the formula I was showing here. So I want to change the weights with some logic. So what is this logic? It's very simple. I'll take the old weights minus The learning rate. Okay, so I will talk about learning rate. At what pace you want your system to train or your system to learn. Okay, it's always better to go with a smaller value so that your system will slowly learn. That is very simple. Like, I have a 10 years old guy, uh, two 10 years old people. So of course both are at the equal standard. Okay, so what you will see, what you will suggest, whether a person 10 years old means probably is fifth class, whether you want to move a particular person from fifth class to 10th class, or you want to study sixth class, seventh class, eighth class, ninth class, and 10th class. So there is a fair chance of a failure of the guy moving directly from fifth class to 10th class, but there is a very less probability of failure if a person step by step going and then learning things, and then he will definitely achieve the objectives of 10th class examination. So this is what exactly I'm trying to tell here, that go slow, let your system learn slowly. If it is a fast learner, so there is a chance that you know it will not predict you properly. Okay, so for now I kept a learning rate as 0.005. So the learning rate into the difference, so the difference is minus 3.3, and then the values of these, my x1, x2, x3, x4. So I'm going to calculate this for my all weights. So if I use this formula, so my new weights are like this. So instead of point 0.1, point 0.1, point 0.1, point 0.1, because I'm not changing the bias here intentionally. I want to keep things very simple. Okay, so I changed my weights to 0.11, 0.13, 0.14, 0.26. Did you see some pattern here? W4 changed a lot because the value of this x4 is high compared to this value. So these values also will influence the weights, because whichever input is contributing to the maximum error, that guy will get a penalty with respect to maximum change. Okay, no penalty as such, but penalty means that guy has to change more. Okay, so now these are my new weights. Let's try with these weights and then see my outcome. Okay, so now I used these weights here, new weights. Now my output is changed from 1.7 to 3.5. Okay, so your neuron is actually learning. You understood, right? So I'm moving slowly towards 5. This is no logic, no magic here. It's a very simple common sense. Okay, so now it is 3.5. My difference is minus 1.419. My learning rate will be fixed for everything, for all iterations. So these are my new weights, and then let's use the new weights here and then perform the same thing. Now I got 4.39. Okay, so again I will go with the back propagation. I'm getting a new weights, repeat 4.7, repeat 4.87 or 887, repeat 4.951, 4.979, 4.991, 4.996. It keep on goes. Okay, sometimes it may not exactly will give you 5, but it will be as close to that, and certain time you have to end your logic, because if you keep on trying for 4.999999 something, so we call that as a overfitting. Okay, so these are number of epochs in case of neural networks. So reduce that, you manage it such a way that it will not overfit, but at the same time it gives you a decent output. Okay, don't expect any of the machine learning models will predict you 100%. Don't do that, it will not. Okay, as simple as that. So finally we continuously repeat it, but as it's keep on reducing the variance, like for example here, see, finally I try to prove that it is 5, but it may not be 5. If I change this to something, somewhere it will be, uh, you see, it will never be 5. Okay. So now you understood, right? So this is how. So now we did it only with one record. So but actually the systems will do this for n number of records. Okay. And then it will try to reduce the overall weight, overall the difference of actual versus the predicted value. The regression is exactly works like a regression. Hope I know you're all aware of the regression technique. So same thing we're doing. It's keep on changing the weights, nothing else. Okay. So probably now you understood, how this forward pass, that is perceptron. Perceptron is all about summation, some product plus some activation, and then finding the error, and then propagating that error back to your weights is called back propagation, nothing else. Okay. And these are some of the domains where neural networks being used very heavily. I don't think we really required to go through that, but at least I personally worked on smart cities, and then education side. I spent some time in agriculture side when I was with the government of Andhra Pradesh. We did a lot of agricultural based use cases. Okay. So I think I can share this deck, so because these things will be available in any of if you do Google, so you'll get all these things. Okay. Because so in the interest of time, so I just want to show you something. See, this is what our model. Okay. uh, this is a camera installed in one of the road. Okay, so predominantly you will find lot of cameras owned by the government, and then various communities as part of the smart cities to reduce the the crime and all. So I think everything is integrated at the command center, and they keep police keep watching all the cameras. Okay. So now customer approached us. Customer here is Hyderabad police, so they approached us, boss, in this COVID-19 pandemic, can you guys help us to detect who is maintaining, who is not maintaining physical distancing, and who is not wearing a mask. So these are the two things we did. Probably in 1-2 weeks time frame we did it, because they want us to be delivered on priority basis. So this we did sometime in early April after lockdown. Okay. So this is an image from surveillance camera, and it will automatically detect the people, and whether the distance between two people or 6 feet at least, or 3 feet at least. That is all configurable thing. So if customer wants over 3 feet is fine, but actually COVID-19 expectation is 12, sorry, 6 feet, right? So we did this. So this is how it works. It's continuously works. Okay, so it takes every frame, and then it will create a bounding boxes around a person. The moment they coming closer, so it will become a red means an alert for me. So though I may not be understanding who is that person, because we don't have that information, and also it is very difficult to detect who is that person, but we can definitely help them in such a way that which circles or which junctions people are violating a lot, or which junctions people are not violating a lot. So this will be very useful information for police to deploy their the patrolling people into those areas, so that at least they will maintain some distance manually. They will start announcing, or they will put we call it as public announcement systems. Okay. Or variable message boards. Okay. If you see in any junction, you see some electronic displays, right? Where your helmet, don't over speeding kills you, something messages, the variable message boards. Okay, so those things can be leveraged in those areas where there are many violations. So these are the types of benefits, and there is always a competition across various commissionerates and various uh, commissionerates are. Okay, I'm sorry. Okay, so it will be very useful for a police station level, because we have a, because these are all cameras are fixed. So each police station, so we'll compare, in which police station there are many violations. So those SIs or CIs, you know, responsible for those police stations, so they will take appropriate action. So this is purely we did it based on CNN. So solution is, leveraging existing surveillance cameras for video streaming, adapting deep learning techniques to identify people, and measure distance between people in pixels with the help of camera height, angle, and focal length, and aggregate number of people and number of violations per minute per camera and record the statistics. Visualize the data on geospatial dimension to plot the heat map and hotspots. So these are visualization part, but the core part here is that, how neural networks can identify a person, by various filterings and all. And then of course we trained these models, because none of the models available in the market will work here. Because if you see, if you google it, YOLO 3, 4, or 5, whatever, so they trained with some cameras, or images from US or UK or Australia, or some countries like that. So the environmental conditions there are very different from here. See, for example, here road itself is a very difficult to detect, and then people, moving, there and here, there is, unfortunately, because I'm not saying that India is bad, but that is how we created our own culture, right? So that's how it will be very difficult for any models directly work with Indian conditions. So we took a lot of real-time images from 4 5 cities where we are actively operating in India, and we trained those models with some tweaking, and then started working. Of course, the uh, accuracies are very decent. We achieved F1 score of 85 to 90. I think that is more than enough for this type of use cases. Okay, so actions, focus on hotspots and deploy appropriate resources, police resources at hotspots to control more patrolling in identified hotspot areas. Challenges, video quality is sometimes is always a challenge, and there is always a network lag, because these cameras are supposed to feed the, video streaming, and we don't have a 5G type of communication. Still all these running on 4G, but is 4G is also fine, but all these camera live stream supposed to come through, a wide network to the control station, and from there we have to take a pipeline to our model. Okay, so there is a network latency and network issues, and then the quality is also not very great in India, because of the pollution, or sort of smoke in the air, etc. So it's not very clear compared to any US markets, etc. Okay, so technology stack, simple Python pre-canned models with transfer learning, CPU based model training, and hybrid user interface for quick go to market. OpenStreetMaps is the one which we use it for mapping purposes. So this is another one, as I told you, the two use cases I was talking about. See, this is the difference, guys. The left side is the one, will do very good with the ready-made models, but none of these models work in this environment, because this is what my real environment. Right side is what, one of the Hyderabad place. Okay, somebody is probably standing in queue for liquor purchase, if I'm not wrong. Okay, so that is a difference. So this is a very big. Here what you will find, first of all, finding the face itself is a problem, and within that face we are trying to detect whether a person wearing a mask or not. Okay, so that is a real-time challenges. So I think we did a pretty decent job. So all these reds are actually not wearing the mask, and green supposed to be wearing the mask, something like that. Okay, so these things is available in various forums, because Hyderabad police posted all these things in various forums. So solution is same thing. There is not much of difference. Detect faces first, to understand the person, detect the face, and then mask. So there is a three-step process. And sometimes if a poster is there on this pole, so that face is continuously detecting, because face is a face for neural networks. So those challenges we faced, and then we managed it, all those things. Okay, so this is another example of video analytics, where by using our existing same cameras, we will find out, are there any potholes on the road. So a municipality person may not go to all the roads of the city to understand where all potholes are there to fix. So in this, we used leveraged existing cameras, and then it automatically, build a model. It automatically detect everything, and then consolidate everything, and prepare a report, and then send it to the required agencies. So this is how we'll say that, oh, these are the places where we have potholes. So this is more or less the same thing. I don't want to spend too much of time. Okay, so this is uh, typically the architecture, reference architecture. Okay, so it should have some data acquisition layer, because data may come, because your model data may come in the various formats, like either it is a streaming from social media like tweets, or a streaming from cameras, RTSP is a format, we'll get it. Okay, or it's supposed to take some value, some data from existing ERP systems, or existing other computer applications, or you may get some data from unstructured way, or system logs, for example, semi-structured type of data. So you will get data in various forms, and then you should be in a position to accept the data either through APIs, FTPs, or database connections. And then you have to store the data somewhere, and then you have to enrich the data somewhere, and then based on that you have to finally annotate the data, and then store it back again. Once after you annotate, annotation, we have so many tools like CVAT, or probably image, what is that, label image. So these are the two tools we generally use. So once after annotation, so finally your model training will happen, and then we have to validate this model, and then we have to optimize this model, and then finally push your code to some DevOps pipelines, like a GitHub type of thing. And then finally either the GitHub will be on the cloud, or probably in your local. So finally from there, wherever I want to deploy this, I will pull that into their ecosystem, and then we started working from there. And then we all the outcomes will be presented onto some dashboarding or visualization tools. Okay, so this is a typical uh, architecture. So but it has its own shapes and formats, so that is purely depends on your ecosystem, but these are the steps required at various scales. Okay, so probably a very quick example. So it is the same thing in Python. Okay, so uh, this is what my input. Okay, so 00 is one my input, 01 is another input, 10 is another input, 11 is input. So it's a simple, you might have studied in our engineering, OR gate and gate type thing. So trying to just, so this is what my input, and this is what my output. Okay, so if inputs are 00, inputs means x1 x2. Okay, output is y. So my x1 and x2 both are 0. My output supposed to be 0. If either of that is 0, then also 0. Now both are 1. It's supposed to be 1. So this is what my data input. Okay. So it is more of an AND gate testing. Okay. So then, as I said, you can give some weights. Any weights, whatever we discussed in the Excel, we are giving a weights, and then we are giving some bias value, and then we're also giving the learning rate. So whatever we did in the Excel, we are doing the same thing in Python. Okay, nothing great about it. Okay, so once after it goes through, see, hope you are aware of the optimization, because it will purely work on the optimization. Okay, so I'm not going through all these things. So this training is happened. See here, see this is what. Okay, so if you see the Excel what I was showing, right? So here probably I don't know how many iterations we did, probably some 10 iterations. Okay, so with the 10 iterations we got this accuracy. Okay, so this is the number what I'm talking about, the 10. So either it is 10 or 100,000. Okay, so those many times it will go through. Okay, the cycle, so that it will learn by itself. Okay, so after this training, so this is the training part. So training part in the sense, training is all about weights. Okay, nothing else. It's keep on changing the weights. Okay, don't worry about that at all. Okay, so after that, so finally it's created the weights like this. So we started with point 1 and then point 2. So finally it ended up with the 2.0 and 2.0, 6 and 7. And then bias is also getting changed, because I was not changing the bias in my previous example to make things very simple. So here bias also will change. So bias is minus 3.433. Okay. And then finally, if you give various inputs, like for example, now I will give zero point 0.5 and zero point 0.5. So zero point 0.5 was never discussed in the output in our earlier thing. So it is giving zero point 0.2. So then that's up to you. What is your threshold value, and then take a decision. Say for example, I will keep zero point 0.9 and zero point 0.9. So it is giving 0.57. Okay, so what you can do is you can keep your threshold as zero point 0.4, and then anything beyond zero point 0.4 you can take as a 1, or less than zero point 0.4 you can take as a 0. So for example here, 0.9 is close to 1 and zero point 0.1 is close to 0, then effectively we should get a value of 0. Okay, so now it is giving zero point 0.2. So still okay, because I'm keeping zero point 0.4 as a threshold. So zero point 0.2 will be considered as 0, and anything beyond zero point 0.4 is considered as, say for example, I want to keep this zero point 0.7 and zero point 0.7. So both of them are relatively closer to 1. So it should give some zero point 0.4 or something like that. Okay, 0.36. So then it's up to you how you want to take these values. Zero point 0.7 is all business decision. Okay, so whether you want me to keep zero point 0.3 as a threshold, that is up to you. So let's assume that both are greater than zero point 0.5. So this is 0.27. So we can put 0.25 as a threshold. Anything below will count as 0. Anything above count as 1. So this is how your neural networks works. And I just want to, before that, I just want to give you a very simple example. Say for example, I'm talking about 0 0 0 1 1 0 0, sorry, 1 1. So this is what my regression equation, and this is what my output. Okay, so I just want to compare. Okay, so this is x1, this is x2, and this is y. Okay, so this is what my simple data given to me. Okay, simple. So let's form a regression equation on that. Okay, what it will give. Okay, so what I will do is, let's go to data and data analysis, and go to regression. Okay, and then my y range is this one. So I will add this as y. My x range is this. Okay, and the labels included, and the output I want to keep it somewhere here. This is, sorry. Okay, so here. Okay, so let my output be here. Okay, so let's run this regression. Okay, so this is supposed to be same as this. Okay, so that is what. So if you run for more time or less number of time, probably it is equal to 0. But if you see, This is 2, 2. We are getting point 0.5, point 0.5 minus 0.25. I think quite not matching. R square is 81. Because if it is a small data, so probably neural networks may not be too good in this particular situation. If at all we have millions of records like this, right? So obviously neural networks will give, but effectively, though it is not matching today, but these values supposed to match with these values, then I can say that you know your model probably at least it's a second level of comparison of your data. Okay, your model. Okay. So here I'm saying that so this is what my intercept. Okay, so this is what my intercept, that is this area, and the beta values are these one coefficients. X1 is 0.5, 0.5. Here it's coming 2 and 2. Okay, so because I think we overtrained this model, if I'm not wrong. Let's make this as 100. Okay, and let's change this learning rate to some little bigger value. Say, okay, let's try this, how it works. Because you keep on experimenting, guys, so that it will be fun for you, as well as to understand the underlying concepts clear. Okay, so now it's probably much better. Okay, intercept is 0.25. Here it is 0.14 and 0.5, 0.5. Okay, so these two supposed to match. Okay, so you don't worry about it. Okay, guys, I'm done from my side. Any questions for next 10 minutes? I'm glad to respond. Okay, stop sharing. Okay, so Sohini, that see, YOLO is a pre-trained model. Okay, it is a CNN based model, and it's a predefined model by somebody else. Okay, see, now to be frank, today what happens? No one actually creating the layers by themselves, or the number of neurons in a particular layers themselves, because somebody keep on doing. So let me see, let me open YOLO, and then probably you'll understand, right? That is definitely not the discussion, but let's talk about that. Where is its network? See, this is what the network of the YOLO 3. Okay, so they are using, see, for this to understand, I think we are all should be aware of what is convolution neural networks. Okay, convolution neural networks is all about taking the the issues or shortfalls of the fully connected neural network, okay, or FNNs or DNNs, or densely connected neural networks. Okay, so with that, what happens? Every neuron is connected to every neuron of the next layer. So for, if at all it goes to hundreds of neurons in a layer and then hundreds of layers, then it is a multifold, okay, weights it has to calculate, and it is very heavy with respect to computing, and it's also, takes a lot of time, and also your model is not well, is not responsive when it goes to production. So that's the reason convolution came in. So where, after the initial initial neurons, all the hidden neural layers, neuron layers, will be created with CNNs. So CNNs, what it does is, it will not connect everything to everything. It will only connect. See, for example, this is how. So each area will be, only that part will be connected to one neuron, or what, I cannot say this neuron, we call that as a filter. Okay, so each of these, box will be connected to one filter. So every filter will give me some outcome. Say for example, if the filter here, so this guy is talking about one red filter, the red filter, or probably this nose, right? So if I take that filter, it gives me to what exactly the attribute of the overall image, but at this particular area, what is the attribute I'm going to capture it. So I'm going to capture a nose from that. Okay, if at all, say for example, it's not about, you're always detecting the puppy here. I want to detect whether this puppy is wearing a mask or not. So if at all puppy is wearing a mask or not, I want to find out where is the mouth, okay, or nose of this puppy. So I will train this particular area during my training process, so that what it does is, the moment it will find this type of contours, it will detect that as a, it will learn as a nose. So whenever I'm sending a new image, wherever I will find a similar patterns, because all those weights and filters are already stored as part of my weights of my network, so it will automatically detects those contours, and then it will throw, a probability as an outcome. So based on that, I will decide whether it is a nose or not. Okay, so like that, I can find, each filter will help me to find various attributes of the overall image. Because if this pixel, if you take, this is 1000 by 1000. Okay, so 1000 pixels horizontal, 1000 pixels vertical. So I need, the first layer should have those many neurons. Each neuron will be taking one pixel as input. So 1000 into 1000, right? So those many neurons I require. And then as I want to progress, so there will be too many weights. So to compress those weights and then also find some attributes of those particular part of an image, so we'll go with the neural convolution neural networks. So you can take my email ID or LinkedIn, and then I'm glad to spend some time in the interest of time. Okay, because we do a lot of such work every day. Sometimes we always face problems, etc., but we have to keep resolving that. Where is this? Okay, image classification and image recognition. Okay, I will tell you, it's a very straightforward question. Thanks for asking. See, Sohini is a person, right? So first of all, I have to detect whether it is a human being or not. So that is called detection. Okay. So detection is whether a particular image is a human being or not. That is the first thing. Detection is whether that person, or the recognition is whether the person is Sohini or not. Okay, you understood, right? First, identifying detection of a human being compared to some animals. Okay, so that is called detection. I find the all faces of a particular image is called detection, and recognizing those faces based on my historical data or my backend data, whether it is Sohini or somebody else, that is called recognition. See, I always prefer OpenCV. Okay, I see. My simple request to everybody is, do not complicate your solution. Okay, solution should be as simple as possible. For example, in my example 00011011, I don't think so. We require a neural networks there, but as I taken that as a toy example. But there are so many other sophisticated or simple tools available which will not take any of your computation and storage. Neural networks is very compute intensive processor. So I suggest you go with traditional ways to find or solve the problem, because at the end of the day it is not to showcase your skills, guys. Okay, please be very clear. It is not that Shaila knows something. Shaila is here to solve the problem. How I can solve the problem? Being a data scientist, I know how to solve the problem, which methods to apply, what data transformation is required, etc. So that is my headache. But my solo intention is to solve the problem, not to complicate things and then showcase my skills. So use OpenCV where to the extent possible, and if that is not solving your issue, then yes, neural networks. And the neural networks is not also solving your problem. Probably reinforcement learning. Okay, because not everywhere you can use it, but you can use it and try it. So how to optimize weights? Optimization of weights is very simple, Ankit. If you are still there, uh, so we have time. You guys are there. Ankit, if you are there, I can show you something. Otherwise, we'll take it offline. It's already 7 o'clock.
You can explain it, sir. We have the recording.
Okay. Go on. 1 second. Okay, so this is how optimization works. Okay, uh, let's take some Excel. So let's take the same example, regression. Okay, so now I will not go through regression technique. So I will use a optimization technique. Okay, optimize. Okay, so let's optimize. Okay, so optimization, how optimize? So for this, we all aware that there are three parameters required. One is beta value, and one is x1 beta 1 for the related to x1, and this is x2 related to beta. Okay, beta 2 related to x2, whatever. Okay. So now I want to find out these values such a way that I will reduce my error. Okay. So what is my error? Error will be y minus y hat. So 1 second, guys. Can you stop recording for a minute? Hello?
Yes, sir.
Can you please stop recording for a minute?
Yeah, yeah.
Hello?
Yes, sir.
Yeah, you can switch on now. I don't know anybody there, but anyway, quickly 2 minutes I will close it.
Yeah,
Okay.
okay.
So it's all about the optimization. Okay, so optimization is a very simple concept. Say for example, I have two values x1, x2, and then I have to predict, say for example, y. Okay, so if you go with a regular regression equation, so we'll get something. But with the optimization also we can do something. So for example, this is a of course underlying is regression equation. So regression equation require beta value, beta 0, beta 1, and beta 2, and then you will calculate a predicted value by using this formula, because I don't have any values in that formula for now, but that value is supposed to be calculated by my optimization technique. So just like that, I am creating y hat with some blank number. So let's remove this. Okay, so this is what. Okay, see now I don't have any values in these beta values, so I pretend that I have these values and I'm creating a regression equation. I created my expected values. Okay, and then the error, how we calculate the error. So my actual value minus predicted value whole square. So I will get the sum of squared errors. So this is what error I calculated here. So finally, this is what the overall model's error. So my objective is to optimize uh, these values so that I can minimize my error. So let's go to data and then go to solver here, and then you can go with a simple equation. Okay, so in this solver, what is your objective? I want to minimize this value. What is this value? I want to minimize this error. Anything, whether it is a neural networks or regression or any model for that matter, we are all trying to reduce the error. So this is what my objective function. Okay, you're fine, minimizing this, but by changing what? So I'm going to change the values of these three values so that I can minimize my error. Okay, so I don't have any further constraints here, because generally if any constraints here will go here, but as I don't have any constraints, simply solve. So the moment you say solve, so it will find out, randomly it will go through a lot of steps, and then it will keep on incrementing, decrementing these values, make sure that it will try to reduce the error. So this is the minimum, the lowest error, your optimization platform giving you back. So you cannot reduce this further. Okay, so that you can say that this is an optimal value of error by manipulating these values. Okay, so this is how your regression also works. This is how your neural networks also works. Okay, so with that, I'm going to conclude the today's session. So thanks, Sukanya, for giving me this time to interact with people. So thanks a lot here.
Uh, Thank you so much, sir, for your time. We learned a lot from your explanation, and we'll
Sure, sure,
hopefully go through this domain again to make
sure,
ourselves.
sure. Thank you.
Yeah.
Thank you.
Thank you, everyone, for joining.
I did presenter, right?